In this video, we will learn how slope ratio and percent grade conventions are used in civil construction work. So maybe your question is, why is this topic important? Think about this. When we build buildings, it's all about building the building straight, level, plumb, flat, square. You get the idea. But with civil construction, we usually have to build our work with some amount of inclination. Really, we seldom build anything flat because our grassed areas, our pavements, and our underground utilities must all have some type of a gradient in order to provide for the flow of water or wastewater. In short, it's got to run downhill. To help us build in this non-level requirement, then, we have the two conventions, slope ratio and percent grade. For short distances or fairly steep gradients, we use the slope ratio convention. And for more gradual inclinations and longer distances, we use the percent grade method. Let's see how the slope ratio works first. Remember that this convention is used for short distances or steeper gradients. The slope ratio is defined as the horizontal run, always in feet, over a constant vertical rise, which is always 1 foot. We usually like to write it like these examples here. The run over the rise, and remember the rise is always 1 foot. Let's see some graphic examples then. This is pretty straightforward. If you look at the 4-to-1 example here, you can see that for every 1 foot of vertical rise, we must have 4 feet of horizontal run. And likewise 3-to-1, 2-to-1, and 1-to-1. This may look somewhat familiar to you if you've done any drafting work. A 1-to-1 is essentially a 45-degree angle, although we don't use degrees in civil construction very much. So this would resemble the shape of a 45-degree triangle. Let's look at some real plans and better understand how this works on the job site, okay? All three of these images are what we would call a cross-section view. You can explore that topic further in another video. Beginning then at the upper left, by my pointer here, this view is a simple swale, which a swale is just another name for a shallow drainage ditch. Note that in this case, the slope ratio is given in both a minimum and maximum. And this is a little confusing because the minimum at a 4-to-1 is really the steepest allowable slope, and the maximum at 10-to-1 then would be the flattest allowable slope. Well, what would the maximum allowable depth be at the swale? Okay, this would represent a level line from the ground over to the center of the swale. So what would the maximum depth be at the center line of the swale at the 4-to-1? Well, it's 10 feet. So if we divide 10 by 4, that's 2.5, and 2.5 times 1 tells us that the distance from here to here, the depth at the swale at a 4-to-1 slope, would be 2.5 feet. And if it were a 10-to-1, obviously 10 feet, 1 foot, so this would be 1 foot deep here. Pretty neat, huh? Our second example to the right is another section view. This time this section is a roadway excavation, most likely through a hill, and probably with blasted rock because we see these very steep slopes. We can see one line of the pavement shown down on the bottom here, one lane of the 2-lane road. So let's start in the upper left corner where it says rounding. As the excavation begins, there's a 2-to-1 slope, or flatter. This would depend on the nature of the material, but definitely they're in soil here. And then there's a little reverse slope of a 10-to-1, and the idea is that any soil that might erode would be caught on the back side of that slope. And then as the rock is encountered, the slope steepens to it says 0.5, that's a 1/2-to-1. Okay, so for 7 foot of depth, a 1/2-to-1, then another 10-to-1 bench, 4.5 foot, and then a 1/4-to-1 on down to the bottom here, and then a 10-to-1. So this would tell the contractor exactly how this cut through this hill and through this rock would be excavated. Our last example is a simple earth dam, and again, let me get a highlighter here. And again, we can see how this convention is used. The waterside slope of the dam is a 3-to-1. The backside slope of the dam is a 2.5-to-1, and the trench that holds and ties the dam into the rock underneath the dam is a 1-to-1. Let's move on and take a look then at the percent grade convention. Remember, we said that this method was used to specify more gradual inclination and or for longer distances. Percent grade is defined simply as the vertical change in feet over a constant 100-foot horizontal distance. And here we see a graphic example of that. We have 3-foot vertical in 100 feet. Remember, the 100 is the constant, so 3 in 100 tells us then that this is a 3% gradient. Sometimes we need to find what the actual percent gradient is. So let's look at another example. And in this case, we've got a vertical rise of 4.3 feet, and we've got a horizontal run of 345 feet. So we simply divide the rise by the run, and we find in this case that our slope is 1.25%. Let's look at an example then from a plan. In this case, we're looking at a sanitary sewer profile. And note, let me get the highlighter, note then how the gradient for each run between, these are manholes, how the gradient for each run varies and how it is specified in the profile view to 2 decimal places. Let's find another example. And in this case, we're looking at a street profile. Well, this looks about like a roller coaster. If you just look at it the way it's drawn, what the situation is that normally in profile views an exaggerated scale is used, and we talk about this in another video. So it's really a pretty gradual slope, and let's see if we can figure that out. This is a 1.99% slope, so that's essentially 2 feet in 100 feet. That's not really very steep when you think about it. There's a change point here. This is a 0.95% slope, or just under 1 foot per 100. And then what looks like a really steep hill here is simply 1.85 feet per 100 feet. This is a typical road section, and in this case we're going to see how both the slope ratio for shorter, steeper gradients and the percent grade for flatter gradients can be used to fully illustrate the work. So over here on this side, we're actually into a cut situation, and we can see that a ditch is to be excavated to drain the water on the side of the road. And let me get a different color here. We see a 4-to-1 slope. We see a 6-to-1 slope. We see a 6-to-1 slope over here. It's already circled in blue. And if we look at the top surface of the road itself, right here and right here, running out to the shoulder, we can see that that is at a 2.6% slope, or 2.6 feet per 100. Let's summarize what we've learned then about slope and grade. Most civil work is inclined or at a gradient to provide for the flow of water. Our 2 conventions, slope ratio and percent grade, are used to define the required inclination of the work. Slope ratio for shorter, steeper distances, or percent grade for gradual inclination or longer distances.